Hi everyone, I'm Sleepless Scientist. Tonight we're not just lying back under the stars, we're drifting up and down through and beyond the boundaries of everything familiar. Above us is the roof of the solar system. Below us, well, we'll find out. But before we go too far, let's start right where we are. Not on Earth, not even in orbit. Let's zoom out. Farther still. And now let's ask, is this even the center of anything? It isn't. I'd love to know where in the world you're listening from and what time it is for you. Let me know in the comments below. I'm always curious where these quiet little science stories are drifting to, and if this video helped you while you were there. Now relax, take a deep breath, and join me gently on this evening's journey. You hover in space somewhere just outside Neptune's orbit, watching the solar system hum quietly in the darkness. And you can't help but notice it's all strangely tilted, not like a stack of dinner plates or a well-arranged fruit tart. No. It's more like someone threw everything into a lazy spin and let it settle where it wanted. The solar system isn't standing upright. It doesn't even have an upright to begin with. You're floating in one of the spiral arms of the Milky Way galaxy, specifically the Orion arm, a little minor spur tucked between two much more dramatic swirls, Sagittarius and Perseus. Think of it as the cosmic equivalent of a sleepy suburban cul-de-sac. Nothing too flashy, but it gets plenty of starlight. You aren't near the center of the galaxy that's tens of thousands of light years away, a turbulent core with a monster black hole chewing on radio waves. No, you're out here where things are quieter, calmer. The neighborhood kids, those being, say, Earth-like planets, can ride their orbits without too much galactic traffic. And that's comforting, until you realize something weird. The sun is actually bobbing. Yes, bobbing. Like a rubber duck in a bathtub, the whole solar system gently wobbles above and below the plane of the galaxy as it orbits. This slow, wave-like motion once every 60 to 70 million years might even correlate with extinction events on Earth. That's right, some scientists think dinosaurs may have been wiped out, in part because of cosmic timing. A galactic bump, not just a rock from space. Still up for debate, of course. And while you're thinking about ducks and galaxies and dinosaurs, here's a little irrelevant but lovely detail. In 2006, a team discovered a massive cloud of alcohol floating in Sagittarius B2 near the galactic center. No joke, enough alcohol to make 400 trillion pints of beer. So next time someone says there's nothing above us, kindly remind them there's booze in the sky. But let's zoom back to you. The solar system orbits the Milky Way at a breakneck 828,000 kilometers per hour. You don't feel it, of course. You're just hanging here half asleep, staring at Jupiter and Saturn like they're nightlights. But every second you're riding shotgun through the void, tracing a lazy 225 million year long ellipse around the galactic core. That journey is called the galactic year. You and me and every weird little dust mote in your closet, we've done this maybe 20 times since Earth formed. If you're feeling old, it's okay. So is the sun. And still, the solar system doesn't sit still. It spins on its own tilted axis relative to the galactic plane like a vinyl record carelessly thrown on a spinning table. There's a certain poetry to that, you know. Everything drifting slightly off-center. No fixed top or bottom. Just orbits within orbits. Rotations within rotations, wheels within wheels. It makes you wonder who decided which way is up. There's no sign in space. No compass needle twitching toward galactic north. Instead, up and down are choices we make based on convenience. Astronomers arbitrarily defined the North Galactic Pole as the direction above the Milky Way's plane perpendicular to its spiral disk. It's a bit like picking which way to hang your painting and declaring it the official orientation of art. But still, that doesn't stop us from assigning meaning to directions. Up feels hopeful, down feels heavy. And when we say we're going above or below the solar system, what we're really saying is we're exploring the space that isn't in the flat, familiar pancake of the ecliptic. The ecliptic is that imaginary sheet where all the planets roughly align like toppings on a very orderly pizza. So tonight, as you lie back and sink into sleep, imagine you're lifting away from that pizza plane, floating up out of the solar flatness into the still dark zone above it. There's not much up here, but there's enough. Above and below are filled with things we barely understand. Ancient stars, rogue planets, cometary ghosts, fields we can't map. Even gravity doesn't pull the way you expect out here. The rules start to fray. And speaking of unexpected, octopuses have 3 hearts and blue blood, and no one really knows why they're so intelligent. But that's for another bedtime. For now, just drift in the quiet knowledge that your solar system is a humble disk, gently tilted and wobbling, floating in the suburban calm of the Orion Arm. And up is just the start. You keep drifting upward away from that flat pizza crust of planets, slipping beyond the ecliptic, where the solar breeze thins out like the last puff of a candle. Here you enter the realm known as the galactic halo, a vast ghostly sphere surrounding the entire Milky Way. It's an odd neighborhood, not where you'd expect most of the galaxy's action to be, yet it holds secrets older than the stars you know. The galactic halo is a home to some of the oldest stars in the galaxy, ancient relics of a time when the Milky Way was just a baby. These stars are sprinkled sparsely like cosmic breadcrumbs left behind during the galaxy's messy assembly. They don't follow the neat spinning disk pattern of the galaxy's main body. Instead, they wander on random elongated orbits, drifting in all directions like wayward bees buzzing far from the hive. And here's where it gets intriguing. Scientists still debate exactly how the halo formed. Did it grow from the Milky Way, swallowing up smaller galaxies? Or is it a leftover from the primordial cloud that birthed our entire galaxy? Some think it's a mix of both, a cosmic patchwork quilt stitched together over billions of years. Adding to the mystery, the halo isn't just stars. It's wrapped in an enormous cloak of invisible dark matter. This dark matter is the galaxy's unseen backbone, its mysterious glue holding everything together. You can't see, it cannot touch it, but you feel its gravitational pull everywhere. In fact, the halo is the place where dark matter's influence becomes most obvious, tugging silently on stars and gas clouds. Now, just to throw in an odd fact that doesn't quite fit, but makes you smile, some globular clusters, tight groups of stars, orbiting in the halo contain stars that are 13 billion years old, meaning they formed when the universe was barely a toddler. That's older than your great-great-grandparents' great-great-grandparents times 10. But back to the present. As you float through the halo, you're surrounded by a faint glow of diffuse gas and high-energy particles. This hot, thin gas extends far beyond the visible stars, heated to millions of degrees by ancient cosmic explosions. It's almost like the galaxy's breath, an invisible exhale of plasma and energy. And the strange part, we don't fully understand how this halo gas remains so hot without dissipating. Some scientists suggest that mysterious cosmic rays or dark matter interactions keep the temperature up, but the debate is far from settled. This place is also where ancient stellar relics from small galaxies devoured by the Milky Way can be found. Imagine little cosmic fossils preserved in the halo, telling stories of galactic battles from billions of years ago. By now, you're well outside the busy bright disk where planets like Earth spin in predictable orbits. Up here, the neighborhood feels ancient, quiet, and hauntingly beautiful. And while you're floating in this ghostly sphere, here's a quirky fact: some researchers believe the halo might even contain dark galaxies, collections of dark matter and gas. with hardly any stars effectively invisible except for their gravitational footprints. It's like a cosmic game of hide and seek with invisible players. So as you gently float in this sparse but significant realm, remember above our solar system lies a vast ancient halo, a stellar attic filled with the oldest stars, clouds of scorching gas, and the ghostly pull of dark matter. It's a silent guardian of our galaxy's past, holding clues to how everything began. And speaking of silent guardians, did you know wombat poop is cube-shaped? Scientists are still puzzling over how they manage such geometric precision. Keep that image in your mind as you drift, because the universe is full of surprises, both grand and oddly chassade. Now you begin to descend downward if such a direction truly exists out here. You're slipping beneath the solar system's mid-plane below that tidy swirl of orbits, like diving under a spinning vinyl record into the dark velvet where gravity starts to whisper rather than shout. As you drift lower, a subtle but powerful force keeps tugging at your awareness. Gravity, the quiet architect of all this cosmic symmetry. It's gravity that flattens the solar system into a disk like flour sifted onto a table, and it's gravity that holds the planets hostage to their paths around the sun. But here's something beautiful: you're not just orbiting. You're balanced, teetering on invisible strings pulled equally by forces you'll never touch. The solar system's shape, its flatness, is no coincidence. All of it, from Mercury to Neptune, and the oddball trajectories of comets and asteroids, was born from a rotating disk of gas and dust. Over time, that rotating cloud collapsed into a plane. Angular momentum demanded it, as if the universe couldn't help but spin itself into elegance. As you float below this plane, you notice how remarkably thin the planetary layer is. The orbits of all major planets are tilted just a few degrees from one another, with Pluto forever dramatic wandering off at a steeper slant, like that one kid who rollerblades to class in a helmet covered in stickers. Yet even this neat planetary dance isn't perfectly flat. There's a wobble. The disk ripples slightly like a flag in a faint breeze, and some scientists suspect these ripples might be caused by interactions with passing stars, unseen dark matter clouds, or even the slow pull of the Milky Way's own uneven gravitational field. Here's a weird, wonderful fact: if you dropped a rock straight down from Earth perpendicular to the solar system's plane, it wouldn't just fall endlessly. Eventually, it would be tugged back like a marble in a bowl. The plane acts like a gravitational well, softly attracting everything back toward its center. Even comets that venture far above or below the disk tend to curve back, eventually drawn by the sun's quiet command. But what really defines down here, that's the tricky part. Unlike Earth, where gravity pulls things toward a well-defined center space, is ambiguous. You define below only by choosing a reference point, and in our case, it's the ecliptic plane. So when you say you're going down, what you're really saying is you're moving away from the regular into the fringe. Scientists still debate how sharply the solar system thins out below the ecliptic. Some models suggest a sudden fall-off in material, while others think there's a fuzzy gradient, a diffuse cloud of particles slowly fading into the nothingness. In short, we're not entirely sure what's beneath us. But we do know this: there's far more small stuff than big stuff out here. Millions of asteroids, frozen rocks, and forgotten particles orbit at odd angles, some barely held in place, others tumbling freely like unclaimed socks in a cosmic dryer. And we still haven't discovered most of them. You pass through these regions slowly, gently. You don't bump into anything, it's far too vast for that. But you sense it: the solar system has thickness. Not just distance, but depth. A dimension that usually hides behind the headlines of 9 planets and a star. Yes, we still count Pluto at bedtime. He needs it. Now here's a fun detour: crocodiles can sleep with one eye open, keeping half their brain alert while the other naps. Scientists still debate exactly how they pull it off. But wouldn't that be nice, especially during long galactic flights like this? Back in space, you're brushing against the outskirts of the scattered disk. A region full of icy objects like Eris, Haumea, and Makemake. These oddballs have elongated orbits that dive far below and above the solar system's main plane, suggesting they were flung out long ago by some mighty gravitational kick. And what delivered that kick? Possibly Neptune. Possibly something else. Some astronomers whisper about a hidden Planet 9, an unseen giant tugging subtly at the farthest objects, bending their orbits like an invisible shepherd. Still unconfirmed, of course, but tantalizing. So here you are beneath the familiar. The sun is now a distant spotlight shining from above, and the planets orbit silently in a plane that feels almost flat from this new angle. It's a bit like standing under a glass dance floor, watching ballerinas twirl on invisible strings. You're in the solar system's shadow, not dark, but quieter, cooler stranger. And just as full of stories. You're drifting now towards something odd, not in substance, but in structure. It's the South Galactic Pole, a direction that doesn't lead to any actual pole you can touch, but rather a conceptual one straight down from the galactic plane 90 degrees off the Milky Way's face. It's like standing at the bottom of a frisbee looking up and wondering who threw it. From this angle, the Milky Way looks like a glowing smear in the sky. A gentle wide arc, thin in places, cluttered in others. You might expect the view down here to be quiet, but it hums with invisible whispers, magnetic fields threading through the darkness like forgotten wires behind the walls of a house you didn't build. Yes, space has magnetism. The galaxy is laced with a magnetic field, faint, mysterious, and everywhere. It's shaped by the movement of ionized gas, the rotation of the galaxy, and possibly even by the explosion of ancient stars. But scientists still debate how this field first formed, and how it stays stable across such absurd distances. From down here, you feel the solar system's own magnetic bubble, the heliosphere, pressing outward. It's shaped like a windsock puffed up by the solar wind, and it distorts as it moves through the galactic medium. Imagine a goldfish swimming in syrup, dragging a bubble of influence behind it. And here comes a curiosity: this solar magnetic field flips polarity every 11 years. That's right, like a cosmic mood swing, the sun's north and south poles switch places regularly. Nobody knows exactly why, but it's likely tied to the sun's rotating plasma and tangled magnetic lines that stretch, snap, and reconnect in a kind of cosmic rubber band fight. Now, as you continue your descent toward the galactic south, those magnetic whispers grow fainter but not gone. Here in the depths, the interstellar magnetic field still guides cosmic rays and shapes plasma clouds. It even bends the paths of charged particles like a soft gravitational hand. And some particles, they're travelers. You may be brushing past atoms that were born in supernovae before the solar system ever existed, wandering for millions of years, before being nudged this way by unseen forces. One of them might hit your cheek. Don't worry, you won't feel it. Speaking of supernovae, did you know that bananas are slightly radioactive? They contain potassium-40, which emits tiny amounts of radiation. Not enough to do harm unless you're hoarding thousands in your spaceship pantry, which, please don't. Back to space. You're still falling slowly, silently beneath the solar system's gravitational midline, and the stars behind you are starting to thin out. That's because our galaxy is a disk, thin and wide, like a stretched-out pizza with anchovies made of hydrogen. The farther down you go, the fewer stars you see. The light dims, the energy quiets, but the patterns become more profound. You start to see symmetry, how the arms of the galaxy spiral, how star clusters organize themselves, how magnetic fields curve in arches that echo geometry more than chaos. You feel like you're witnessing the galaxy's skeleton, its scaffolding of invisible forces. And here's a wild theory some researchers entertain: could the galactic magnetic field influence biological systems? Could cycles in solar and cosmic radiation subtly affect life on Earth, migratory birds, human health, or even global climate? It's speculative, but it's being studied. And that in itself is fascinating. You pass through regions where the magnetic field twists, where charged particles spiral like confetti. And just for fun, imagine Earth's own magnetic field, which protects us from solar radiation. That magnetic bubble has saved your DNA more times than you can count. Without it, we'd be toast. Or more accurately, sterilized toast. Scientists still argue over what causes galactic magnetic reversals, if they even happen. The sun flips its poles. Earth does too every few 100,000 years. But has the galaxy ever done it? The evidence is thin. Perhaps the galactic field is more stubborn. Or maybe we just haven't been around long enough to see it misbehave. You're now far enough below the solar system that everything familiar is above you. And strangely, it feels like looking up from the bottom of a fish tank. The planets swirl above like strange goldfish, the sun, a radiant anchor. And beyond it, the thin disk of the Milky Way stretches into shimmering infinity. And just beneath you, something awaits. A wall, a membrane, a frontier. You're approaching the edge of where our star's influence fades, and interstellar space begins. But for now, you simply float, between poles, between definitions, wrapped in magnetic fields that twist like forgotten dreams. Listening to the silence interrupted only by the soft hum of particles you can't see. And while we're down here, did you know that jellyfish have survived 5 mass extinctions? They just float. They glow. They endure. Maybe they're onto something. You're slipping towards something subtle, something soft and invisible, but strangely powerful. It's not a wall exactly, and not a line either. More like the edge of a weather system you didn't realize you were inside until now. You're gliding into the heliopause, the border where the solar wind finally gives up and lets the galaxy in. And you're not alone. Voyager 1 passed through this strange frontier in 2012, followed by its quieter sibling Voyager 2 in 2018. Those little metal messengers, each no heavier than a motorcycle, have traveled farther than anything else we've built. And now you're catching up to them, or rather to their wake. Out here, the solar wind thins to a whisper, closer to the sun. It's a wild, rushing storm of charged particles, mostly protons and electrons, barreling outward at hundreds of kilometers per second. But here it slows, choked by pressure from the interstellar medium. It's like running full speed into fog. The heliosphere, the giant bubble blown by the sun, reaches out to roughly 120 astronomical units in all directions. That's 120 times the distance between Earth and the sun, or about 18 billion kilometers. Yes, billion. It stretches far past the planets, past the Kuiper Belt, until it thins into this edge, the heliopause. And what lies beyond, something colder. Something less familiar. Interstellar space. The place between stars. Here's a fun twist. The shape of the heliosphere isn't a perfect sphere. Scientists once thought it looked like a comet's tail, long and teardrop-shaped, but new evidence suggests it's more like a croissant. Yes, a cosmic croissant. Layers folded by magnetic fields, puffed up by solar breath. Delicious. The Voyager probes have already tasted this frontier. Their instruments recorded a sharp drop in solar particles and a sudden rise in galactic ones. Imagine walking from a loud concert into a library where whispers from far-off places suddenly become audible. You hover in this transitional space and something shifts. The sun's voice fades. The chorus of other stars, distant whispering, grows louder. You're no longer in the solar system in any practical sense. You're riding the tide of the Milky Way now. And speaking of tides on Earth, the ocean tides are caused mostly by the moon's gravity. But did you know that the sun contributes about a third of the tidal pull? The next time someone thanks the moon for low tide, remember the sun's doing its part too quietly from a distance. Back to space. The edge of the heliosphere isn't sharp. It fluctuates, pushed inward and outward by the strength of the solar wind and the pressure of the interstellar medium. Think of it like the surface of a giant balloon flexing slightly with cosmic weather. Scientists still debate whether Voyager 1 really left the solar system. It crossed the heliopause, yes, but it's still well inside the Oort cloud, the real outer shell of our system. So what does leaving mean in a universe where there are no fences, only fading boundaries? As you float alongside Voyager's invisible path, you realize something sobering. The signals from these probes take over 22 hours to reach Earth. And they're fading. One day they'll fall silent. Then they'll just drift. Forever. Tiny monuments to human curiosity whispering into eternity. And that's poetic. Because everything in the solar system is doing the same. Drifting, orbiting, waiting. Moving outward, inward, sometimes around and around, sometimes through. Nothing here is still. Here's a strange fact: Voyager 1 carries a golden record encoded with sounds and images from Earth. Music, greetings in dozens of languages, the laughter of a child. Just in case someone or something out there wants to understand us. It also includes a recording of brainwaves. One woman thinking about love. That's in space now. So are you. You're hovering at the boundary between solar breath and galactic breeze. You can feel the shift. The sun is still behind you, glowing softly. But you're facing outward now, toward everything else, toward the unknown. And just to pull you back to Earth for a second, the smell of rain petrichor comes from oils released by plants and a molecule called geosmin. It's one of the most comforting smells we know. Out here, there's no petrichor, no rain, no soil, but there is memory. Because this boundary, this moment, is where memory meets possibility, where the story of the sun ends and the story of the stars begins. You take one last look at the fading shape of the heliosphere behind you, this shimmering, flexible envelope the sun has carried around like a cape for billions of years. And then without a sound, you cross the threshold. Welcome to interstellar space. You've crossed into the dark, past the heliopause, past the croissant-shaped solar shield. Out here, there's no more solar wind to push on your cheeks, no planetary gravity to beckon you home. You are in the space between stars now, and the first thing you notice is that it's not empty. Above you, around you, inside the quiet, there is something vast and spherical, the Oort cloud. You can't see it, of course. No one can. It's invisible to telescopes, silent in all wavelengths. But it's real, predicted by Dutch astronomer Jan Oort back in 1950, and still one of astronomy's most ghostly residents. You're drifting inside what might be called the solar system's exoskeleton, a shell of icy objects surrounding the sun, at a distance so great that light from it takes nearly a year to get here. Billions, maybe even trillions of icy bodies orbit in this massive cloud. Not tightly packed like marbles in a jar, but spread across a sphere perhaps a light year wide. That's about 9.5 trillion kilometers. It's less like a wall and more like a haze, a gentle fog of ancient leftovers. These are the forgotten building blocks of the solar system, too far away to feel the warmth of the sun, too frozen to join the fun closer in. But when one of them gets nudged by a passing star, a gravitational hiccup, or a rogue planet, it begins a long, slow fall inward. And if it comes close enough, it becomes a comet. A frozen ghost that burns a trail of fire through the inner solar system. You might be floating past the next great comet right now. It's just a speck here, cold, asleep. But someday, in a few thousand years, it might blaze across Earth's sky and be named after a graduate student who happened to be looking up at the right time. Scientists still debate how far the Oort cloud extends and whether it's truly spherical or more like a thick halo warped by the galactic tides. Some models even propose an inner and outer Oort cloud with different histories and compositions. The truth is, we've never directly seen a single one of these icy relics. But we see their tracks, their ghosts. And here's something to twist your mind. Some of these objects may not even belong to the sun. There's a chance a few were stolen from other stars during the chaotic days of the solar system's youth when gravitational billiards was the rule and nobody had a fixed orbit. You're surrounded by icy orphans. And speaking of orphans, did you know that octopuses have no bones and can squeeze through holes the size of their eyeballs, totally unrelated to the Oort cloud, but also weirdly comforting? Flexibility is power. Back to our shell. The Oort cloud isn't just a boundary. It's a transition zone, a blurry border between what is ours and what belongs to no one. It's where the sun's gravity still wins, but just barely. One strong nudge, one stellar encounter, and any of these icy bodies could defect to another star or escape the galaxy entirely. It's hard to overstate how huge this region is. From the inner solar system to Pluto is about 40 AU. The Oort cloud, it might reach 100,000 AU. That's 500 times farther out than Pluto. You could fit the entire planetary system into this shell 100,000 times over. And yet here in this frozen fog, the pull of the sun is still just strong enough to matter. You're floating now through a place no spacecraft has ever gone. Voyager 1 is headed this way, but it won't arrive for another 300 years, and it will take 30,000 years to cross it entirely. Yes, you read that right. 30,000 years. And while we're on the topic of long journeys, here's a charming aside. The average sloth moves at about 0.24 kilometers per hour. That's 30,000 years to cross a school parking lot, if you're lucky and no one parks in your way. But unlike a sloth, you're not moving slowly. You're drifting in mind, in story, in a space filled with ice, gravity, and silence. The Oort cloud is your blanket tonight, a shimmery, invisible comforter that wraps the solar system like a secret. Somewhere in this fog, theoretical objects called sednitos may be lurking, distant bodies with bizarre, elongated orbits that suggests something massive may be hiding beyond. Planet 9 again. A myth, maybe, or a missed discovery. Scientists are still searching, still puzzled, still hoping. And isn't that what this whole journey is about, you in the dark? Surrounded by unseen ice, listening to the whisper of the sun's gravity stretched to its limit. And somewhere in the future, a single icy rock begins to turn. Just a little. Pulled, called, awakened. You drift onward deeper into interstellar space, a place few beings have ever imagined, this intimately, much less visited. You've slipped through the solar system's final veil, past the Oort cloud's icy silence, and now for the first time you are truly beyond. There are no planets to orbit, no sun to anchor you, just you and space itself. But this space is not empty. Here the medium is different. Not the vacuum you might picture, not a perfect hollow nothing. No space between stars is filled with whispers, tenuous gas, drifting dust, and an almost spiritual kind of silence. This is the interstellar medium, and it's been traveling for billions of years, colliding, coiling, cooling, collapsing. It's mostly hydrogen with a trace of helium and specks of heavier elements. but it's thin, far thinner than anything you've known. A few atoms per cubic centimeter. So thin you could float through it forever and never feel a breeze, but so vast that it shapes galaxies. Here's a beautiful contradiction. It is empty and infinite, yet it connects everything. As you move farther out, you realize something poetic. This is what the sun has been pushing against its entire life. Every gust of solar wind, every flare, every pulse of magnetic breath resisting this ancient mist, trying to carve a bubble for its children. Now you're outside that bubble. You're in the galactic sea. The starlight is different here. Older, fuzzier. It comes from all directions, not just one blazing orb. And the temperature, a chilly 2.7. Kelvin just above absolute zero. You're brushing up against the cosmic microwave background, now the faint afterglow of the Big Bang itself. It's everywhere. Even here. Even now. And speaking of ancient things, the interstellar medium is not just passive. It's the cradle of stars. The dust and gas here will someday collapse under its own gravity, begin to heat, to spin, to ignite. And a new sun will be born. Maybe with its own planets. Maybe with someone else drifting into sleep under that sky. Scientists still debate how dense the interstellar medium gets in certain regions. Some areas seem unusually thick, so-called interstellar clouds, while others are oddly empty, as though something swept them clean. One such mystery, the local bubble. But we'll get there. For now, you glide alongside stray particles, some of them energized into cosmic rays, the wild children of the universe. They zip past you at nearly the speed of light, ejected from supernovae and black hole jets thousands of light years away. Some of them hit Earth's atmosphere every second, triggering little showers of subatomic rain. You might have had one pass through your head today. Maybe while you were brushing your teeth. Here's a weird tidbit. There's a real theory that cosmic rays can affect cloud formation on Earth. That means part of your local weather might be decided by exploding stars on the other side of the galaxy. Talk about long-distance influence. But cosmic rays aren't just weather makers, they're also messengers. By analyzing their composition, scientists can reverse engineer the history of distant galaxies, supernova remnants, and ancient magnetic fields. They're little telegrams written in proton and electron, and yet they're dangerous too, to astronauts, to electronics, to the DNA of any poor microbe caught without a magnetic field to protect it. That's one of the great unsolved puzzles of space travel, how to shield living things from this high-energy barrage. Still, you float on. You pass through this soft glow of starlight and radiation carried not by wind, but by momentum. Out here, there's no up or down, no east or west, only inward and outward. The sun behind you, the galaxy ahead. And just to give your brain something to chew on, sea cucumbers breathe through their butts. That's right. They have a respiratory tree in their rear end. Completely unrelated, but undeniably true. Even the weirdest parts of nature keep you company out here. Back in the vastness, the interstellar medium begins to change. You sense faint patterns like the first wrinkles in a bedsheet. Fluctuations in density. Hints of pressure. You're approaching something. Not a wall, but a zone, a region that has a name but barely any borders. The local bubble. A strange cavity in space where the gas is thinner and hotter than usual. It's like the solar system lives inside a long-forgotten cosmic explosion, drifting through a supernova's ghost. But we'll explore that properly next. For now, just float. The sun is a distant speck behind you. Ahead, the strange, warm emptiness between the stars. An emptiness filled with potential. This is the space your ancestors pointed at when they looked up in wonder. The space every atom of your body once traveled through. The space where new stars are born, and where old ones fall quiet. It's not empty. It's everything. You're beginning to feel something strange in this darkness. Not heavier, just different. As if the quiet has thickened slightly. The emptiness isn't quite so empty anymore. You're moving into a region with a history, a scar, a fossil in space. This is the local bubble. It sounds gentle, like a soap film hanging in a breeze. But it's really a wound, an ancient cavity in the interstellar medium, likely carved by multiple supernova explosions over the last 10 to 20 million years. It's a vast bubble of hot, low-density gas surrounding the solar system. A quiet reminder that stars die with fireworks. You can't see the edge, but you feel it. The gas out here is thinner, about 1/10 of the density of the average interstellar medium. But it's hotter. Around 1,000,000 degrees Kelvin. Not enough to toast your fingers. Space is too sparse for that, but enough that the atoms here move like caffeinated bees, and the size roughly 300 light-years across, big enough to hold thousands of stars, or one peaceful spiraling sun with a handful of orbiting rocks and a bunch of icy tag-alongs. The solar system didn't create this bubble, it just drifted into it. Scientists think it entered the local bubble about 5 million years ago, sometime around when our early ancestors were first learning to walk upright. Since then, we've been gliding through this strange void without even knowing it. And the shape, it's irregular, warped, not spherical like the Oort cloud, more like a bruise compressed in places by neighboring bubbles blown out by other long-dead stars. Scientists still debate whether the local bubble is actively expanding or if it's been mostly hollowed out, and now just is. Some believe there are magnetic fields on the bubble's boundaries that trap cosmic rays and guide star formation. Others think the sun might be approaching its exit. Either way, you're inside it now. Here's a fun digression. While you drift, elephants can't jump. Zero vertical. Their legs just don't work that way. Majestic, massive, ancient, but completely earthbound. Unlike you. Out here, you're surrounded by starlight, but also by history. The very atoms floating past you, the ionized hydrogen, the stray oxygen nuclei may have come from massive stars that lived fast and died spectacularly. These were Type II supernova stars, at least 8 times the mass of the sun, that burned through their fuel and exploded outward in a burst of light and force that reshaped space. In fact, some scientists think our entire little region of the galaxy is full of overlapping bubbles from these explosions, a kind of cosmic foam. The local bubble is just one popped cavity in a much larger quilt of supernova scars. You may even be drifting through the remains of stars whose light first reached Earth when dinosaurs still ruled the planet. And that's wild. Here's another twist. The very fact that our sun is in this bubble may have helped make Earth habitable. Lower density around us means fewer interstellar clouds to interfere with the heliosphere. Less compression. Less cosmic radiation. It's possible we've had a relatively peaceful cosmic ride thanks to the echo of ancient stellar deaths. You're flying now toward the upper edges of the bubble where things start to grow a little denser again. Stars are closer here, constellations forming clusters like small towns after a stretch of desert road. One such cluster, Scorpius Centaurus, is thought to be the source of the supernovae that carved this bubble in the first place. Imagine that an entire region of space shaped by a stellar family reunion gone nuclear. And as always, we're still uncertain, still speculating. The boundaries of the local bubble are fuzzy. Mapping them means looking at the way light from distant stars dims and scatters like trying to reconstruct a fog bank by how headlights bend inside it. But we're getting better at it. In 2022, researchers used data from the Gaia spacecraft, along with measurements of star-forming regions, to create a 3D model of the local bubble's surface. And here's the beautiful part: it showed that our little sun is floating at the center of this cosmic cavity, and the walls of the bubble are studded with newborn stars. In other words, the shock wave of those ancient explosions didn't just clear space, it triggered creation. The pressure may have squeezed nearby gas clouds, igniting new stars along the bubble's edge. Death followed by life, collapse followed by rebirth, and right in the middle is us. You float quietly now, just listening. The bubble around you vibrates with old violence and new potential. You can almost hear it breathing. And to pull you briefly back to the random again, did you know flamingos bend their legs backward at the ankle, not the knee? Nature is full of illusions. So is space. So here you are, surrounded by the ghost of stars you never knew, traveling through the hot, quiet hollowness left behind when something unimaginably bright died. And in this bubble, like in all bubbles, the edges mean more than the center. You're almost at the wall. What lies beyond it is the thicker dark. You hover now at the very edge of the local bubble where its skin starts to wrinkle and fold into something more textured. It's like drifting toward the rim of a dried tide pool, quiet, yes, but hinting at deeper currents below the surface. As you pass beyond the bubble's blurry boundary, you find yourself descending not through gravity, but through density into the galactic midplane once again. And here, everything begins to darken. Not because the stars are gone, but because something lies between you and them. Dust. Not household dust, not the stuff under your couch or inside your keyboard. This is interstellar dust, carbon-rich particles, silicate flecks, and molecular clouds thick enough to blot out entire constellations. You're falling into what astronomers call the dark rift. You might have seen it before unknowingly. On a summer night, when the Milky Way stretched overhead like a river of light, there was a dark band running through the middle. That's the rift. A river of dust, thousands of light years long, coiled like ink through the luminous galactic disk. And now you're inside it. It feels muffled. Light from nearby stars grows softer, redder. Not because the stars are different, but because dust scatters blue light like Earth's atmosphere does at sunset. You're surrounded by the colors of twilight, not because it's night, but because it's crowded. You're also not alone. Deep in these dusty lanes, stars are being born. The same particles that block your view also cradle newborn suns. The pressure, gravity, and chemistry of these clouds spark fusion in hidden cradles of warmth and light. Some of the most famous star-forming regions, like the Eagle Nebula or Orion's Belt, are just denser knots in this dusty river. Scientists still debate just how thick these dust lanes are and how much they interfere with our ability to map the galaxy. They block visible light, sure, but in infrared they glow like embers under a blanket. That's why modern telescopes use infrared eyes to see the heat of what can't be seen. Now here's your random bedtime brain tickle. The smell of books, that comforting old library scent, comes from the slow breakdown of chemicals like lignin and cellulose. In other words, paper breathes. Even silence speaks. Back in space, you're brushing past molecular clouds, some of them dozens or even hundreds of light years wide. These are dense regions where hydrogen clumps together into H2 molecules, the coldest, darkest places in the galaxy. Temperatures here drop below 10 Kelvin. So cold that atoms barely move. So cold that even light slows down metaphorically, if not literally. You float gently among them, tracing the boundaries where dense knots of Kyo are on the brink of collapsing into stars. It's slow motion drama, cosmic tension, in the final pause before ignition. And did you know the sun probably formed in a place just like this? Roughly 4.6 billion years ago, it was cradled in a molecular cloud like a hidden pearl, its birth sparked perhaps by a nearby supernova. We think this because of traces of radioactive elements in meteorites, the kind that only form in stellar explosions. You may be drifting near the exact kind of environment where our star was born. The memory of its birth is all around you. And here, in this murky river of gas and dust, you start to notice something else: motion. Not the simple circular orbits you're used to, but streaming, rippling, flowing. The galactic disk isn't still. It waves. Astronomers have discovered that the Milky Way's midplane undulates like a flag caught in a breeze. Some of it is caused by gravitational interactions with dwarf galaxies or dark matter clumps. Some of it is still a mystery, but you can feel it. The solar system itself bobs up and down through the galactic plane every 30 to 40 million years. It's subtle, like a sigh, but it might matter. Some researchers even suggest that this gentle oscillation might disturb comets in the Oort cloud, sending them inward toward the planets. Could this periodic journey through the dust lanes explain cycles in Earth's history, extinctions, climate shifts? Again, nobody knows. But the patterns are there. And speaking of patterns, in 2019, Gaia data revealed a strange snail shell ripple in the disk, a spiral of stars slowly twisting through the galaxy. The ripple was likely caused by a gravitational event millions of years ago. You may be drifting through the residue of that disturbance now, so here you are, in the dark, surrounded by dust that hides stars and births them, beneath a galactic sea that ripples and flows with invisible forces. You're not just beneath the solar system, you're beneath understanding, in the folds of what we can't quite see but can't stop chasing. And while we're here, one more sleepy surprise: chickens are the closest living relatives to T-Rex. That means you probably passed a dinosaur descendant today without knowing it. They're still with us. Everything echoes, including you. You're still gliding through the galactic midplane, the dusty undercurrent of the Milky Way, when something begins to press in, not pressure exactly, but presence. You can't see it. You can't feel it. But it's there, tugging on everything, holding everything. This is the pull of dark matter. Now, this isn't some cartoonish cloud of shadowy goo. It's not made of atoms. It doesn't glow. It doesn't clump like gas or ripple like starlight. In fact, it doesn't interact with light at all. That's why it's called dark. But it still pulls, and the numbers, they're outrageous. Astronomers estimate that about 85% of all the matter in the universe is dark matter, meaning everything you've ever seen: planets, moons, stars, tea kettles, ducks, toenails, all of that makes up just a sliver of what's really here. The rest, invisible scaffolding. You're floating now through this invisible architecture. Above you, below you, everywhere around you, dark matter halos wrap the galaxy like ghost hands. They reach far beyond the spiral arms shaping orbits holding galaxies together, even influencing how clusters move on cosmic scales. And here's the kicker. Without dark matter, our galaxy would fly apart. Based on how fast stars rotate around the galactic center, the visible mass simply isn't enough to hold it all together. Something else must be providing the extra gravity. Something invisible, silent, loyal. Like a gravitational lighthouse you can't see, but always feel. Scientists still debate what dark matter really is. The leading idea is that it's made of WIMPs, weakly interacting massive particles. Others suggest Axion's tiny hypothetical particles that might drift like a cosmic fog. But so far, no one's caught one. It's maddening. The universe has a secret ingredient, and we can't even taste it. But it's not just out there. It's here. You're swimming in it. Earth, too, is thought to drift through the galactic dark matter halo. There's even a theory that once a year around June, we pass through a denser stream, creating a dark matter wind that blows silently through everything. And now for your odd fact of the night. Sharks can detect electrical fields as weak as a billionth of a volt, meaning they could technically sense the electricity in your muscles from meters away. Nature has ways of sensing the unseen. Maybe someday we'll build a shark for dark matter. Back in space, you start to notice something else. The movement of the solar system isn't quite a perfect circle around the galactic center. It's lumpy, wobbly, like trying to walk across a trampoline. That's dark matter again, warping the fabric of motion, adding subtle chaos to otherwise elegant orbits. And the wildest part, there are hints that the Milky Way's disk itself may be warped because of dark matter's influence. The outer regions of the galaxy seem to twist like a vinyl record left out in the sun. A bend, a ripple, an asymmetry we still don't fully understand. You're flying through that bend now. It feels like a wave frozen mid-crest, a tension that never resolves. And just when you're thinking the darkness couldn't get weirder, there's a theory that dark matter might clump, not into planets, not into stars, but into dark stars, objects made entirely of dark matter, slowly collapsing under their own gravity, emitting no light, orbiting nothing visible. If that sounds like sci-fi, well, it is. But it's also on the edge of mainstream science. Because when you don't know what 85% of matter is, the door's wide open. And here's a moment of existential dread sprinkled with science. If dark matter interacts only via gravity, then it might pass right through you, Earth, the sun, and the entire solar system without slowing down, like a whisper through a dream. You're surrounded by that whisper now. You can't touch it, but it holds you. And isn't that the strangest comfort? That the invisible keeps the visible from flying apart. It's like gravity's secret partner, the backstage crew of the cosmos. No applause, no spotlight. But everything would fall without it. Now, while you're letting that settle in your mind, here's a thought reset. Pigeons can sense Earth's magnetic field. Not metaphorically, literally. They navigate using something we still don't fully understand. Dark matter may not be the only invisible force our lives depend on. You float on. The stars begin to look slightly more scattered. You've passed through the thickest dust. The waves of the galactic disk are growing shallower. But the tug of dark matter remains constant. A quiet gravity that never sleeps. And so you drift, held, guided, wrapped in an invisible cocoon that no telescope can find. It's not empty here. It's full of something we haven't named properly yet. You start moving again, not upward or downward this time, but sideways, or maybe galactically northward. It's hard to tell when you've lost the traditional meanings of direction. Still, you follow the pull, leaving behind the dusty chaos of the galactic plane. You're headed toward the galactic north, a conceptual direction 90 degrees above the Milky Way's disk. In reality, it doesn't look any different from any other direction in space. But it's the one astronomers agreed to call up. That's right, galactic up is totally made up. But it's useful, and in science, that's enough. As you move higher above the plane, things grow quieter again. The galactic disk fades behind you, like the Earth's horizon receding from an airplane window. Ahead lies an increasingly sparse stellar field, stars, more isolated, more scattered, like punctuation in an unfinished sentence. You're entering a less populated region of the galaxy, above the arms, above the structure. This is where patterns start to vanish. The direction you're heading leads to a part of the sky we call the galactic anticenter, the point directly opposite the galactic core. It's the outer edge of the spiral arm system, where stars become fewer and farther between. You look back over your shoulder, figuratively of course, and see the spiral disk glowing behind you. It's faint now, like a memory, like the lingering light from a closed refrigerator door. And here's something delightful. Astronomers mapped the stars in the Milky Way, the same way old navigators mapped Earth's oceans by looking outward and drawing inferences from the lights they saw. That means your view from above the galaxy is built from centuries of patient star spotting. You're flying above it now, and it's beautiful. Like a pinwheel made of fireflies, or a vinyl record spinning in a velvet void. You may be wondering how high is above. Well, the galactic disk is about 1,000 light-years thick, but you're soaring far beyond that now, several thousand light-years above the midplane. Not out of the galaxy, but definitely looking down on it. And the best part, the higher you go, the stranger the motions become. You notice stars out here aren't obeying the nice circular paths they did in the disk. Instead, some are flying on wild halo orbits, elongated loops that take them far above and below the galaxy in swinging arcs. These stars are like exiles, survivors. They don't belong to the rotating parade of the disk anymore. Some might not even be native to the Milky Way. Yes, that's right. Some of these stars may have come from other galaxies, torn from their homes and caught in our gravity long ago. Cosmic immigrants quietly crossing borders no one can see. Scientists still debate how many of these rogue stars exist and whether they can help us map dark matter. Their paths don't lie. They show where gravity flows, where mass hides. Now, for a weird fact to tug on your brain while you float, bees can understand the concept of zero. That's right, zero. It's not just a number, it's an idea, and one that very few species grasp. So next time you swat one, remember it may be better at math than you think. Back in space, the stars thin further. Below you, the disk looks oddly flat and serene. It almost seems peaceful until you remember the constant supernovae, the solar flares, the comet collisions. From here, it all just looks calm. And isn't that always the case? Look from far enough away, and even the wildest chaos seems like order. You drift alongside ancient stars now, population 2 stars, as astronomers call them. These are old, metal poor, not literally metal-less, but formed before the universe was heavy with elements like iron and nickel. They glow dimly, their surfaces unblemished by younger chaos. And you think this view, it's one only the galaxy itself normally gets to see. The Milky Way rarely sees its own face, but you do. You're in a place of perspective. It's like standing above your childhood home on a hill. Everything makes a little more sense from here. The pattern, the motion, the drift. And still, there's that silence. Space above the galaxy isn't loud. It doesn't shout. It hums. But even that hum is interrupted sometimes. Like when massive stars get kicked out of the disk, hypervelocity stars flung at millions of kilometers per hour by black hole interactions. Some of those stars are flying in your direction. You won't see them. They won't hit you. But they're out here exiled. Some never return. The galaxy doesn't just orbit. It leaks. You're above all that now. Suspended, drifting, dreaming. And before you go too far, here's a comforting non sequitur. Penguins propose to each other by giving pebbles, smooth ones. It's not astronomy, but it is gravity, just in a cuter form. So you hover high above the spiral, the Milky Way sprawled below like a poem, its arms written in stars and gas and questions. You look down not just at your galaxy, but at your place in it. And somehow, in all that drifting, you feel closer to home. You begin to drift sideways again, tracing the arc of a ripple, no, a wrinkle in the galactic disk. The smoothness you just admired from above, that was an illusion. From here, a few thousand light years above the plane, you can see it. The galaxy is not a flat plate. It's corrugated. Yes, like a metal rooftop. Wavy, bending gently up and down in wide cosmic undulations. And you're gliding along one of those waves now rising on a crest, made not of water or wind, but of stars and gas and time. These ripples are real. In 2015, data from the Sloan Digital Sky Survey showed that the Milky Way's disk is rippling like a drumhead after it's been struck. It might have as many as 3 layers of vertical waves, some rising, some falling, all moving. But what's causing them, scientists still debate the answer. One idea, a smaller galaxy, perhaps the Sagittarius dwarf galaxy, passed through the Milky Way's disk long ago like a pebble tossed into a pond, sending waves outward that still haven't settled. Or maybe dark matter lurking unseen is responsible. An uneven clump here, a collision there. The galaxy remembers what hit it. You ride one of those waves now, a crest rising thousands of light years above the mean galactic plane. It's not violent. It's slow, subtle. The kind of motion that takes millions of years to complete one cycle. But it's motion nonetheless. The stars are moving. The dust is moving. Even the gas clouds, those quiet birthplaces of suns, are part of this vast galactic tide. Here's the twist: the solar system is caught in this pattern too. It's not sitting still in a calm river. It's bobbing slowly, moving up and down across the galactic plane every 30 to 40 million years. It's like being on a lazy merry-go-round that also gently bounces. And here's where it gets eerie. Some researchers have noticed that this bounce correlates roughly with mass extinction events on Earth. Every time we cross the midplane where stars and dust are thickest, there might be a slightly higher chance of comets being dislodged from the Oort cloud. One theory suggests that this periodic galactic passage could send icy bullets into the inner solar system, slamming into Earth and shaking the biological etch-a-sketch. Is it proven? No. But it's compelling and spooky. You may be floating now through the same kind of ripple that once turned the sky dark for dinosaurs. Now here's a light-hearted fact to keep your imagination from unraveling. Completely sloths can hold their breath longer than dolphins. That's right up to 40 minutes. They slow their heart rate so much that oxygen just hangs out waiting to be used. Back to stars. These galactic ripples aren't uniform. They vary across different parts of the disk, and their amplitude seems to rise toward the galaxy's edges. That means the outer spiral arms may be moving more dramatically than the inner ones, like the wobble at the edge of a spinning pizza. And maybe that's the best metaphor here. You're riding the edge crust of a pizza made of plasma dark matter and gravitational arguments. It's not neat. It's not even. But it's alive. And what makes it all the more poetic is that these vertical oscillations aren't just happening to the stars. They're happening to you. Right now, as you lie in bed listening to this, your entire solar system is mid-bounce, rising through one of these ripples. Upward, slowly, as if the galaxy were breathing. And speaking of breath, here's a bit of curiosity. The average human breathes about 23,000 times per day. The Earth rotates about once every 24 hours. But the solar system, it completes one bounce up and down through the galactic plane every 60 million years or so. Galactic respiration. One breath every 60 million years. You're floating through the inhalation now. Scientists have only just begun to map these corrugations in detail. Gaia's high-precision stellar measurements are revealing patterns, ripples in star velocities, vertical displacements, oscillations we didn't even know to look for until recently. And each new ripple we find tells a story, a memory, a trauma, a dance. The galaxy is not static. It's a ripple caught in a ripple, a spiral shaken by spirals, a living record of gravitational conflict. And somewhere in all that tucked inside a rippling arm orbiting a middling star is you. So as you ride this galactic wave, consider the possibility that you are not just a passenger. You are part of the pattern, a shimmer in the wave, a brief note in the melody. You are not still. You are in motion, even now. The galaxy beneath you has started to fold inward again, flattening slightly as you descend back toward familiar structures. You've ridden the ripples drifted across the dark matter currents, and now you're sliding towards something familiar but distant, something that mirrors us. You're approaching other solar systems. They don't look like ours, not exactly. Some are messier, some are emptier. Some are oddly elegant, like delicate mobiles hanging in a museum you can't walk through. But they are solar systems, nonetheless, stars with planets circling in silence, each with its own rhythm. And the moment you see them, you realize something odd. Most of them live in disks, too. Thin planes of motion. The same flattening we see in our own neighborhood repeats all over the galaxy. A universal habit of gravity and dust. The reason? It's all about angular momentum. When gas clouds collapse to form stars, they spin. And as they spin, they flatten. The same laws that shaped your dinner plate also shaped planetary systems 10,000 light-years away. You hover over one now, a bright white star surrounded by thin rings of dust and gas. Within that ring, hot Jupiter's rocky world's icy debris. The inner planets are crammed up close to the star, their orbits tight and fast. The outer ones, if there are any, are slower, colder, quieter. You notice something striking. Not all solar systems are well behaved. Some planets orbit at extreme angles. Some move in ellipses so stretched they're more like slingshots than circles. Some stars have no planets at all, just wide rings of dust, promises unfulfilled. And here's where it gets really curious. Scientists have found planets that orbit binary stars, two stars locked in a gravitational dance. Planets circling both like cosmic third wheels. Yes, Tatooine is real, sort of. In fact, the Kepler Space Telescope revealed thousands of exoplanets before its mission ended. Some systems are tightly packed with super-Earths. Others are giants sitting all alone. It turns out that what we call normal 8 or 9 planets orbiting a middling star isn't so normal after all. You begin to drift sideways now through star-forming regions full of promise. Thick disks of gas around young stars, glowing, spinning, gravitationally tense. Some of these disks will become planets. Others will vanish before they can finish forming, swallowed by their stars, or torn apart by nearby companions. And here's a random but perfect fact: sea otters hold hands when they sleep, so they don't float away from each other. You may be floating alone through space, but even otters know the value of sticking together. Back in space, you pass a system mid-chaos. A planet has just been ejected, a gravitational accident. A planetary sibling flung into the void. It's now a rogue planet untethered to any star. And there may be billions of them in the galaxy. Lonely worlds drifting between suns unseen and unloved. But still, there. You wonder, could one of them hold an atmosphere? An ocean heated by internal friction, a chance at life without starlight. We don't know, not yet, but the numbers are staggering. Some models suggest there could be more rogue planets than stars. You pass systems with white dwarfs, ancient stars that have burned out and collapsed into hot, dense cores. Around one of them, you see a ring of debris, dead planets, shredded by gravity. A tiny graveyard. A warning. And yet life goes on. New systems are forming. Gravity does not sleep. Clouds of gas swirl and spin, birthing suns and sorting rocks. Someday, billions of years from now, a creature may look up at a sky we've never seen and wonder, as you do now, am I alone? Here's a fun side fact: while you float among stars, butterflies taste with their feet. It's efficient, weird, and unexpectedly adorable. You pass a trinary system, now 3 stars gravitationally bound trading planets, and dust like kids swapping marbles. The orbits are unpredictable. The light is dazzling. Sunrises here would come in threes with long shadows and overlapping halos. You smile imagining it. And then another odd 1-2 stars circling each other, but no planets. Just a single asteroid caught in a complex figure-8 orbit. Fragile, doomed, but for now still dancing. You begin to realize that solar systems are like snowflakes, repeating themes but infinite variations. Disks and rings, moons and tides, orbits and exiles. Somewhere a planet with a pink sky. Somewhere else a world covered in clouds, thick enough to swim through. Somewhere else again, maybe an ocean with creatures that dream. Scientists still debate whether Earth-like planets are rare or common. The data is promising habitable zones seem to exist around many stars. But we don't yet know what it takes to turn habitability into life. Still, hope is its own kind of gravity. And as you float past the flickering orbits of worlds you'll never visit, you can't help but feel something ancient and true. We are not the center of anything. And that is beautiful, because it means the universe isn't small enough to revolve around us. It's big enough to be shared. You begin to spiral outward now, no longer just floating above or below the galactic plane, but arcing beyond it, where the concepts of disk or halo start to dissolve into something stranger. There is no more up, no more down, no midplane to trace. You're drifting out into orientationless space, and the last bits of galactic structure are slipping behind you. This is where the galaxy begins to blur at the edges. You turn slowly, watching the spiral arms fall away into mist, fading like a campfire's last smoke on a still night. You're moving past the limits of structure, but you're still not at the edge of the galaxy. Why? Because, there might not be one. There is no hard wall, no final ring of stars. The Milky Way doesn't end so much as it fades. It thins. It relaxes into space, like breath released. And this, more than anything else, forces a reckoning. Where does the solar system end? Where does the galaxy end? Where does anything end? Scientists still debate these questions. The Oort cloud could stretch a full light year from the sun, but even that, astronomically speaking, is still just a toe dipped in the ocean. The Milky Way itself is at least 100,000 light-years across, maybe more. Its dark matter halo likely reaches out 3 times as far. But there's no cosmic stop sign. You drift now into a place where stars are so sparse that you go minutes without seeing one. And when you do, it's distant, cold, blue-white, flickering like the ghost of a lighthouse. You're beyond the galactic neighborhood, past the suburbs, on the cosmic highway now. But movement hasn't stopped. The solar system is still flying around the galactic center, yes, but also toward something else. You're headed toward the Great Attractor, a gravitational anomaly in intergalactic space pulling us and all the galaxies nearby slowly in its direction. No one knows exactly what it is. We can't even see it clearly. It's hidden behind the plane of the Milky Way in the so-called zone of avoidance. But it's pulling us just the same, at 600 kilometers per second. Gravity works in whispers, but it never stops calling. And here's something deeply poetic. You're also drifting toward the Andromeda Galaxy. It's on a slow-motion collision course with the Milky Way. In about 4 billion years, our galaxies will merge. Stars will tangle. Disks will distort. New structures will form. A new galaxy, maybe called Milkomeda, will be born. And you're ahead of the curve, watching the edges dissolve before they ever meet. Let's take a momentary pause for a small, absurd fact: platypuses don't have stomachs. Their esophagus connects straight to their intestines. They bypass digestion's dramatic middle act entirely. Just thought you'd like to know. Back in deep space, you begin to lose all sense of orientation. The galactic core is a distant glow. The arms are smudges. The local group of galaxies is becoming visible, a loose collection of islands in the void. You see the Magellanic Clouds, like cosmic freckles. You see Andromeda, a soft smear of light, with more stars than the Milky Way. You're not looking up anymore, or down, or even out. You're just looking. And here's the quiet truth whispering in your ear, now in space direction, is an illusion. Everything is in motion. Nothing holds still. There is no true north. Only vectors, relationships, paths. The solar system has no roof. It has no basement. It has no edge you can tap on like glass. It's a bubble in a field of motion. It floats. And so do you. You begin to understand that above and below only made sense inside the solar system, within that disk. Those planets, that flat sense of orbit and place. But out here, those terms collapse. The structure dissolves. The metaphor breaks. And in that breaking, you feel free. The stars no longer feel like dots on a map. They feel like events burning, humming, waiting. And the dark between them, that's not emptiness. That's potential. And while you're floating in this thought, here's one last curious mental nibble. Mushrooms are more closely related to animals than they are to plants. Yes, fungi breathe oxygen, exhale CO2, and digest food externally, which means your dinner might be having an identity crisis. But that's what this place is too, an identity crisis. The moment when solar system stops meaning something specific and becomes a question. Where does home end and you don't know? And that's okay, because some questions are meant to rock you gently into sleep, like waves with no shore. You are very far from where you started now, far from the planets and their slow spirals, far from the dusty disk and the magnetic whispers, far from the heliosphere's soft edge, and even farther from the place where anyone could point and say, here is the solar system. You've drifted past orientation, past metaphor, past the illusion of up and down. And now at last you're left with one question, soft and staggering. Where does it all end? You float through silence. Not the silence of nothing, but of everything stretched thin. You've entered a space so vast that even the galaxy seems like a detail. The stars are faint now, far apart. You see them in clusters, in groups, in loose associations. No structure, no lanes, just particles in free fall. But still, things move. The solar system is not alone out here. It belongs to a small gang of galaxies known as the Local Group. About 80 members, including the Andromeda Galaxy and the Magellanic Clouds. You can see them now drifting together like lanterns in a dark lake, bound not by ropes, but by shared gravity. The Local Group itself is falling toward Laniakea, our larger supercluster, an immense gravitational continent made of thousands of galaxies, all flowing like rivers toward the mysterious Great Attractor. Everything is falling into something, even the quietest stars. And still there's no edge, no curtain, no boundary where you can knock and hear the sound change. The universe just continues. Scientists still debate whether the universe is infinite or just really, really big, whether space curves in on itself like a sphere or stretches forever like a bedsheet pulled too tight. We've never seen the edge, and maybe we never will. You drift through this knowing. It doesn't frighten you, it comforts you. Because in a universe with no edge, there's always more room for stars, for planets, for curiosity, for whatever comes next. You think back to Earth, to the blue dot, the noise, the light, the billions of lives happening all at once. All of it held inside a little system orbiting a little star, in a little arm of a little galaxy, in a medium-sized supercluster that's part of what? What lies beyond that? We don't know. Maybe other universes. Maybe vast swaths of empty space. Maybe the edge. Maybe a loop. Maybe nothing. Maybe beginning again. And then comes a warm thought, maybe not knowing is the gift. Because mystery gives us motion. We build telescopes not just to see but to wonder. We send probes not just to gather data but to feel small. We ask questions not to get answers but to get closer. Closer to the fabric. Closer to the pattern. Closer to whatever makes all this move. Here's a tiny, sleepy tangent to bring you back to now. Koalas have fingerprints that are nearly indistinguishable from humans. Identical even under a microscope. You could commit a crime with a koala and blame it on them. But please don't. You smile. The universe is big enough to contain galaxies and koala fingerprints. It's doing okay. You drift back toward the solar system not with your body but with your thought. It's still out there, wrapped in its Oort cloud shell, drifting through the local bubble, wobbling in the galactic ripple. Still spinning. Still breathing. And you realize something gentle and enormous there is no above, no below. Only reference points, and relationships, and rhythm. The solar system isn't a marble in space. It's a story in motion. One of trillions. And now as your thoughts begin to slow and your breath softens, the stars begin to blur into a sleepy fog. The gravity fades. The questions dissolve into quiet. You are cradled by drift. You are held by motion. You are part of something that never ends. So rest now. You're safe in the middle of infinity, so we've drifted far tonight. We started just beyond the planets, wondering what lay above and below. We passed through magnetic fields and plasma tides, through ghostly borders and comet clouds. We said hello to Voyager and waved goodbye to the sun's protective breath. Then we crossed the Oort cloud and stepped into interstellar space. We flew through the local bubble carved by ancient explosions and sank into the dust lanes of the galactic midplane. We brushed against dark matter, silent and unseen, and rose to the galactic north to see our home from above. We rippled through waves in the disk, witnessed star systems, alien and beautiful, and finally spiraled outward, asking the hardest question, where does it all end? And we found it doesn't. Not really. There's no ceiling above the solar system, no floor beneath it, just an endless sea of motion and mystery. What we call above or below is only a matter of perspective, useful but not absolute. Every planet, every galaxy, every heartbeat is part of a larger drift. So if your thoughts feel scattered, your questions too big, or your sense of place too small, remember this. You're not lost. You're floating, and you are never alone in that. Thank you for staying with me through this quiet story. Good night, traveler of stars. End of script. Good night.